In this demo, we present the implementation of a virtualized wireless sensor network following a specialized IoT and edge computing software stack called VOStack, proposed by the Horizon Europe Nephele project. The demonstration shows a wireless sensor monitoring application distributed along the Continuum, validating the end-to-end communication among FiPy-based sensor nodes and a web application through the virtual object of the wireless sensor network gateway. The FiPy boards communicate over Wi-Fi. They send and receive data to and from the wireless sensor network gateway using MQTT. A Raspberry Pi 3B has been used as the wireless sensor network gateway. It runs a WAD runtime to communicate via CoAP with its virtual object. VO represents the wireless sensor network gateway deployed in the edge layer. VO communicates with the graphical user interface using HTTP. For managing the sensor nodes, we have developed a MicroPython library dedicated to the sensor life cycle to start the device, establish a Wi-Fi connection, launch a MQTT client, receive the configuration file, and publish measurements using MQTT topics. We have implemented the VO for the wireless sensor network gateway, define the thing descriptor, and the VO files based on the common concept of a servient defined in the Web of Things and implemented in the VOStack using the expose thing and a consume thing functionalities. The VO runs generic functions to print its own status and the status of devices it is consuming, and user-defined functions to read the sensor node data exposed by the gateway and store them in an influx database, and to calculate the average temperature and humidity over 5 samples. In addition, the VO emits an event each time it detects a battery level lower than a defined limit. We have tested the end-to-end communication from the physical sensor node to the web application passing by the virtualized wireless sensor network gateway using the VOStack. A light web application was designed to consume the VO's exposed thing and to display data collected by the sensor nodes. In the future work, we intend to integrate a routing protocol to enable multi-hop communication and extend the wireless sensor network coverage range. In the VO side, we intend to support MQTT and CoAP on both sides of the communication with the devices to support different configuration setups. Additionally, we intend to provide additional periodic functions to calculate important networking metrics such as latency, throughput, and energy consumption.